Okay, well, welcome again. This is the final session of this set of training sessions for Spike2. We look to the future and doing a few example scripts, getting started with scripting, learning the commands, for next loops, etc., etc. So watch out for that. But for this session, when we do it live, that is unlike this version of live, we have a group of, say, 30 people in the room, and they fire at us different requests for the types of channels they wish to record, what type of analysis they wish to carry out, etc. So I'll ask you now to give me some idea of what you would like to do. Now, don't be afraid of this, because many of the channels that people ask for, such as an EMG, could be treated as, say, a nerve signal for somebody else in terms of the types of analysis we may carry out. So please drop things in the chat if you like. But perhaps to start, to get the ball rolling, I'll put up a poll, which is simply asking you which channels you'd like to see added to our experiment. Okay, while you're choosing, I'm running Spike2 version 10.09b. That will be available very soon after we've gone through and tested it. So what's happened to the polling? Relaunch. Should I try that again? Okay, so if you could just put down your preferences, please. That would give us a better idea of which direction we should be going. Okay, so at the moment, Spike data is leading by quite a way. We've got some nerves, not so much on the ECG and blood pressures, although they're starting to build now. Okay, so nobody for ECG. Blood pressure, yes. EEG, yes, and spikes are still very high. Okay, so imagining spike channels being separate, then we, as in sorted spikes and a continuous waveform. And then we'll have the EEGs and EMGs around about the same range of sample rates, you know, in a few thousands of hertz, possibly hundreds for EEG at times, and respiration all the way down to perhaps tens of hertz. So let's set that up then. I'm going to leave the dialogue up. Does that cause a problem with the dialogue up on the screen? You don't see it? Right. Okay. So a reminder. Our sampling configuration, we go to channels, and I'm going to reset everything, make sure everything's clear. Now, a sampling document will always contain a keyboard marker channel. Okay, we need something in the data file. And to that, we can add our 1401 types of channels. And following on from that, we could add in the talkers. You remember, this is a piece of software that allows us to communicate with a third-party device, such as the Delsys Tremio system, the Intan RHD 2000, or our own TIB unit, which takes an I2C or SPI sensor. Okay, so sticking with your request, first of all, we're going to add a spike channel. So we're going to need a wave mark type. Now over here, I'll put that down as WM, and we're choosing the port that we're recording from versus the channel number that will appear in the data file. Okay. Now, as a combination of waveform and marker, we're going to have to set a maximum sustained event rate. And this allocates memory inside of the 1401 to buffer the information coming through. If the spike rate increases too much for too long, then we might fill that buffer. And if we do, we would declare that there's a problem. We may have missed data, and therefore we would stop recording. So therefore, the maximum event rate should be sufficient for bursts of spikes that you might be recording. So I'm setting this to around 300 spikes per second, which is quite a lot. Okay. The next thing I wish to do is then set sample rate. So let's go to something like 40 kilohertz for that. So there's a combination, event rate and sample rate. Now, as with all of the waveform channels, we have units and we have scale and offset. Okay, now we'll look at that scale and offset in a second when we get to something like the blood pressure. Okay, again, there's a combination of waveform and marker. The wavemark dialog also includes the number of points for the shape, the number of points to describe the shape that we're extracting. So 32 data points in this case, and pre-trigger, there will be 10. Now, so often, you would change that size of template when we get to the configuration dialog. Okay, so one other thing to mention with spikes, recording from a single electrode, stereotrode, or a tetrode. So choosing your number of traces here, 1, 2, or 4. Now, if I were to choose 2 or 4, usually we would have 2 ports on the port one next to each other, but it is possible to change the port numbers to whatever you like. Okay, I'm using a Power 1401 here, and that gives me 8 channels of ADC analog to digital conversion on the front panel, and another 8 on the rear, but I've only really got access to the front panel at the moment. So there's our wave mark. If I add a new waveform to this, I'll just call this spike channel, 40 kilohertz as well. Okay, and you'll notice that although the channel number has increased to 2, the port number remains the same at 0. So I'm managing to take a single input and I'm splitting it so that I can capture spike shapes and the continuous waveform all in one. Now, if we take that channel, the new waveform spike channel, we could always add in a derived channel. So this is calculated, constructed once the data has reached the computer. So a derived channel would allow us to apply IIR filters, for example, or for EMG work, you might want to apply a rectify. There is a downsample and a difference function as well. I'm going to leave the derived channel out of things at the moment, but think of it in terms of recording wideband data and then wanting to filter it for LFPs and for spikes. Okay, now if I add a new channel, then we'll go to another waveform. This time we'll go for EMG. Okay, now EMG, let's say 5,000 hertz sample rate. Okay, let's take out any title there. You'll notice channel number could be anything you like here, and yet the port has changed to port 1. Once again, you can choose which input you wish to use. Right, let's say okay to that. If we went further and added in many, many more channels, we might need to set the total number of channels available within the file. So at the moment, we've got 32, of which there are going to be some special channels. There is the digital marker channel, there is the keyboard channel, and there's the text mark channel, which leaves 29 possible channels for waveforms and event type data. So if we need to record more, or we wish to give room within the file to add additional channels later on, we need to use this set button and increase the number of available channel spaces in the data file. Okay, at this point, we can also shift the position of those special channels that we were talking about a moment ago. Okay, so I've gone for EMG with a 5,000 hertz sample rate. Let's get some slow ones in there as well. So let's get respiration. Okay, let's treat that at around 10 hertz in this case. Respiration. What else we got? Nerve and blood pressure ECG. Okay, so let's go new. Let's go blood pressure and new. I'm going to stick to EEG this time. Okay, EEG. Right. Now EEG, let's say 1,000 hertz there. Our blood pressure, I think we should really go for, let's say, 500 hertz for that. So you can see that we've got a mix of sample rates already. Now, a real must is going to the resolution tab, making sure that we've selected the right type of 1401 that you have, and then pressing suggest. Okay. Now, before, some of those channels were, or channel rates were indicating pink or possibly going on to a more reddish color. And that indicates that there's an error compared to comparing what you've asked for and what you're going to get. Okay, so suggest, make sure you've got the right type of channel, and finally, you should decide whether you're recording in the latest 64-bit file type, which gives you virtually unlimited recording time, or the earlier 32-bit file types. Now, if somebody's using version 567 of Spike2, which doesn't recognize the 64 type, you might want to export your file as the old 32-bit, but then you'll come up against a time limit there as well. Okay, so I'd suggest that you should be recording in 64-bit file format, and we go from there. Now, in this case, I've got no need for burst sampling. I've got exactly the right sample rates. I'm recording at 200,000 hertz. I could add more channels in, perhaps more like the Spike channels, the 40 kilohertz type, at which point burst sampling would make a much bigger difference to us. But as you can see here already, by going to burst, we've dropped from 200,000 hertz down to 40 kilohertz. So we've got less pressure on the 1401 in terms of sampling. Now, the downside of burst sampling is we cannot tell you exactly where within the 25 microseconds that these samples were, these channels were sampled. Okay. We can tell you that channel 1 was sampled on the clock tick. All the others would have been sampled as quickly afterwards as possible. Right, so it's your choice to know exactly where the channel was sampled within 25 milliseconds or microseconds or not. For most people, it doesn't make any difference at all. Okay, so we've had a look at the resolution. We've had a look at channels here. Should we do some output sequencer? So should we be creating any stimuli? Would anybody like to give me an idea of stimuli they'd like to create? I'll give you a few seconds to jot something down. What I'll do in the meantime is add some data. So let's go, for blood pressure, we'll use this. And I'm going to go output waveform. Now this is quite small, but it shouldn't matter. To max time, add to online. And we're going to call this BP. Key, let's say it's 1, add. Okay. Right, so I've got some real spiking data anyway, and we could look at some EMG. Okay, let's take a chunk of this. So sampling configuration, oh, sorry. Sample, output waveform, channel 1, so we can take 0 to max time. Now I'm a little hesitant here because I think what we may need to do is a channel process and fill the gaps. the system may be intelligent enough to say, okay, well, that's a data section, then there's a gap, there's no data there. So just to be on the safe side, I'm going to add a fill, and you should now see that there's a line in there. So let's clear that out and add. Okay, so we can set the fill level if we wanted to at any other value than 0. So I'll say okay to that. 0 to max time, add to online. We'll call this EMG, and this is key 2, and add and close. Right, now I can keep going. I will add the nerve and EEG a little later, but we'll start with these guys. Right, so in the play waveform section, I have two items of data that I'm going to play out of the 41 and back in. So at the moment, those two files, for want of a better description, are loaded into the 41 memory. To kick each one off playing, I use key 1 or 2, and I can ask these guys to link to each other. So link from blood pressure to EMG, or I could just tell this guy to cycle 10 times, and I'll do the same for the EMG. It gives me plenty of time to do some analysis. Okay, now you may remember we talked about this memory. The memory inside of the 41 filled with this data is coming from a file at this time. Now, if we wanted to take this configuration away and give it to somebody else, move it to another machine, etc., we may be quite remote from the data file that had this data. So we would have to move the data file with it and relink it, etc. To avoid that, we press convert, and that takes an image of the channel and puts it into the configuration itself. So instead of the configuration being a few kilobytes in size, it's now going to grow due to the extra memory, extra channels that it's got to take on board. Okay, now for most people, we're going to be recording in, they will be recording in continuous mode, but bear in mind you can have triggered mode. So some channels like the EMG might be triggered on a stimulus, whereas all the other channels would be captured continuously still. For those of you doing more pharmacological work, then perhaps a timed mode, so recording 10 minutes every hour. That may be useful with EEG, even sleep, getting a 20-minute section out of every hour, as an example. Okay, so we're going to stick with continuous, but we'll do some work with the triggered views in a moment. Okay, so we haven't done anything with the sequencer, but we have gone to play waveform. We can always come back and add more in a while, because nobody's asked for any stimulus at this point, or stimuli at this point. So let's go run now. So here we have the spike channel, the wavemark dialog that we always get when we start a recording with a wavemark enabled. Now we can switch this off, or we can just ignore it and move on. But if we do ignore it, we have no chance to change the size of the template, or the wavemark area and the template. Okay, so I'm going to hit this here for best guess. I'm going to make sure we're on the right channel here. Okay, so I'm using port 0. And we've got the spikes coming in. Okay, so that's looking not so bad. Make the template width about so. And depending on how our data looks, I might get rid of one or other of the thresholds, because at times, remember, we might get a spike which is triggering on the wrong edge at some point, you may occasionally see the same spike, or what appears to be the same spike, shifted by a small amount. So let's make that a little more exaggerated. So I'll bring this guy down here. If we'll manage to trigger that. No. Let's try it up here instead. There we go. Right, so you can see the same spike moving between those two positions. So that's a bad condition to be in. So bring it down, the upper threshold down, or remove it completely. I'm going to continue with what we've got. So sample data. Right. The configuration that was previously used included an XY plot. So I'm going to get rid of that and continue with just the data view. Now, if you wish to save the configuration, then I suggest setting everything up, recording for a short time, stopping, then saving the configuration, because I find that is the point at which everything that you've done is accumulated and added to the config. Right, so let's have a look at our blood pressure channel. Well, we would usually have blood pressure measured in millimeters of mercury. Okay. And we've got currently a scale of 2 here because I'm using a 10 volt 1401. But imagine this were true blood pressure coming in. Then you might want to scale and change the offset of the data, knowing what 1 volt is equivalent to. So here we're saying that 1 volt of input is equivalent to 20 millimeters of mercury. So if I apply that, you'll see now we've got 100 and minus 100 on our Y scale. Now, if I set the offset to 100 and apply, you'll now see that at minus 5 volts, we're reading 0, and at plus 5, we're reading 200. So that's usually what you would do for calibrating such things as a blood pressure channel. Okay, so let's go and close that. Let's double click, oops, sorry, let's double click in the data view. Right, how do you want to see your data or axes? For those people that are looking at EEG, long-term sleep, etc., time of day. So you're monitoring somebody sleeping overnight, you want to know what's happening at about 4:15 midnight. That, if we draw now, shows the x-axis as the time of day. Seconds is usual, milliseconds is handy, but there's also hours, minutes, and seconds. Right, now if you record the data file, stop, and then display the data once again, changing to time of day, the file has been marked with the time from the computer that the file started. Okay, so you'll be able to see that you did start at 4:15 midnight. Okay, so back to seconds here. You remember rearranging our channels, perhaps having them in this order, changing the percentage of the screen that channels exist in as well. So that was Control and Shift and the drag. Okay, we might want to see also channels placed on top of each other. So now these two channels are sharing the same y-axis. So I'm just going to pop those away for a second. We'll do that again once we're recording. I'll pop this back, and now we start. Okay, so at the bottom of the screen, we've got the spike shapes. The channel above that here is a continuous version of the same. And then we will have EMG, some EEG, and we've got amounts to respiration at the moment, and the blood pressure channel at the top. Okay, Control Q to optimize everything. Right, so what would you like to do now? I imagine that you'd like to take your spike channel and perhaps duplicate it. and that spike channel could have a marker applied to it, marker filter applied to it. So we would see only particular units. So I've hidden everything away apart from the dark blue type 1 unit. In fact, I'm going to put everything back in, update, and change the draw mode, right-clicking on the channel, not to waveform, but to a rate, a mean frequency, or perhaps an instantaneous frequency. So let's go for rates. That's always pretty popular. There we go. So there's our spike channel drawn as a rate display. Now we can change the bin width from what, a second or so to 5 seconds to smooth it out a little bit. Okay, it's also possible to change all the channel colors, background colors, etc. So hopefully, I'm going through a few reminders of things that we've covered in the past sessions. Right, so let's get rid of that, and let's just do something again on the online analysis. Let's just ask you what sort of analysis you might want to carry out again. So we're going to try this. Now, we will cover hopefully all of these, but I'm just trying to see again what the biggest market is for some of the analysis we might carry out. So averages, power spectra, event-based histograms, okay. So really nobody for blood pressure. Okay, one person for cyclical data, right. Okay, so we've got an even tie with the averages and power spectra and these spike-based histograms. So let's have a quick look at the histograms. So while we're recording, I'm going to make this window smaller and go to analysis, where I can find new result views. Or I could go to this item here, new result view, where I can find the list a little more quickly. So something like a stimulus histogram to begin with. Now we haven't as yet added any event channels to the data. That is, channels which could record the trigger time of the stimulator. So I'm just going to use the keyboard for this. So every time I hit a key, that would mimic an event coming in from outside, and that is going to be used as my trigger here for the PSTH. So there's keyboard. We're analyzing channel 1. You'll find that there's only the wave mark type channels and the marker channel, which we're already using for the trigger. Okay, we set a width. We'll try 1 second, perhaps at an offset. Let's set it to 0.2 of a second. And the bin width for our histogram is 1 millisecond. Okay, so let's go new. And because we're online, we tend to use this automatic function as opposed to manual, which says right from time, from a start time to an end time process. We're going to get this updating all of the time here in the simplest form. So I'm going to ask this to update as quickly as it can. That is, unlike it acting as a storage oscilloscope. So you'd have something displayed and then nothing else will be displayed for a certain period of time. And then do I want to process just the last n seconds, or am I going to accumulate all data? So I think we'll do that, accumulating all data as we go. And finally, optimize display after process. Now the next window, this window is going to apply to virtually all of the online processes, online result views you'll be dealing with. If we chose gated by events in place of automatic or manual, then we're setting, or we're asking or stating certainly a start point and a length, a start marker and a length, or 2 markers to indicate the beginning and end of a section in which we wish to process all of the triggers and any other data there. So let's go apply now. Okay, we're looking at, what have I done? Settings. Okay, channel wave mark is 1, width. Oh yes, of course, getting ahead of myself. Okay, so there we go. Now we need a stimulus. So if we trigger S there, there's the marker, the event, the digital marker that's coming from another source, and about that, 0.2 of a second before it and 0.8 of a second afterwards, we've looked to see where the spikes lie and presented them in a histogram here. So if I provide another marker, another S, then there we go, second sweep. Since raster was enabled in the dialog, I'm now getting this distribution pattern so that I can see more clearly what's happening over time, whether the data is spikes are getting sparser or we're seeing more of them. Okay, so there's a PSTH. Now, what would you do with a PSTH now? Well, we could finish recording. We could then copy as text and take that data elsewhere to a stats package, for example, or we could preferably analyze it further within Spike2, perhaps fitting a curve. So if we had something within a PSTH, might have a form of ripple, a sinusoid, either side of 0, and we want to fit sinusoid to that. There are also scripts, of course, which will go further, giving you a measure of the mean of data from the pre-trigger area versus that in the post. So there's a lot more that can be done within Spike2. Now, we're not really going to touch on scripts until a little later, as I'm going to leave that alone for the moment. When we go for waveform averaging, I'll leave the PSTH up here. I'm going to look at EMG. We'll treat this as EMG. No, we'll put some EMG out in a second. So let's connect digital 0, and we're going to 3. I'm just going to check my sampling configuration. So 3 is on port 1. Okay. Let's see that our EMG comes out. So I'm right-clicking to enable toolbars. Remember that we can add scripts and configurations to these two bars from this point, but it is the play wave bar that I'm after. There it is. And if I hit EMG now, there we go. And you notice, because that keyboard channel contained a marker generated from pressing this button here, it forced another update of the PSTH. Okay, so there's our EMG. Right, so perhaps we should take this channel and duplicate it. Okay, and we're going to use the channel process. So we're centered around 0, so I don't need to do anything with DC remove, but I can add a rectify and now a smoothing vector. So add, smooth that reasonably heavily there, and we'll optimize that. So it's not looking too bad. Now let's put a horizontal cursor on that data and just allow us to trigger off the waveform. So now we're going to introduce that cursor 0. Now remember, this is a magic cursor for wave marks, and there's also the iterator when it comes to active cursors. So cursors that are able to find features in waveforms, and once those have been found, then measurements can be taken using their positions and amplitudes, corresponding amplitudes. Okay, so I'm going to ask for data rising through a level, and that's going to be on channel 3A. and the threshold is my horizontal cursor. Now, notice I could also type in a value if I wanted to. Now, delay after crossing. Now, that means that we must detect a threshold, a rising threshold, and we must stay above that for this amount of time. So let's set it quite low at the moment to, say, 5 milliseconds. And say OK. Now, cursor 0 will jump through this data. Now, I'm just using this for the moment to produce triggers for me. Okay, so here we go. And if I go here to measurements and data channel, or analysis to measurements and data channel, I'm going to create a marker or real mark data inside the data file. Now, for our purposes, it's simply a trigger to force an average, in which case I'm going to change to event here. The top third of this dialog, just as we have in the XY view, is to set up what cursor 0 is doing. So it's captured what I previously said. It's a rising threshold. The threshold is H cursor 1. Delay after crossing is 5 milliseconds. I think we'll come back and change that. And we're writing to a new memory channel. But we could also write permanently to a disk-based channel here. So I'll just use a memory channel. Channel title is, let's say, trigger, and our X measurement, because we're in the data view, it's going to be time versus value at point and many other measurement functions if we were using a real mark type channel. Okay, so value at points, slopes, maximum minimums, etc. So I just want to trigger, so I'm treating it as just an event, could also be a marker, and we say new. Okay, and again, asking it not to hang about, just say okay. Those are our triggers coming in. Now, there are a lot of them because I've set a low threshold. I haven't smoothed very much, so I'm getting a lot of transitions there. And that's going to help me show you the waveform average changing really quite rapidly. So we've now got to decide what the width of this histogram is. So it's taking channel 1. We want channel 3. Okay, the width is, say, half a second. No, let's go over a second. You'll see much more that way. With an offset at, say, 0.2 again. The trigger is our M1. New. And again, we have a very similar process dialog. Update the window as quickly as possible and accumulate all data. There we go. So there's our average building based on those triggers. We still have our PSTH, which will pick up on different triggers coming in. Now I've changed from S to T or any other key. They're all in the marker channel. So anything that is seen in that keyboard channel will be added to this or will act as a trigger for the PSTH. Okay. Right, now, along with just a simple threshold detection, we might want to go and find the beginning and end of a burst of EMG to then measure area. Now, I would use the same cursor 0 to find a burst, but then add 2 more cursors, cursor 1 and cursor 2, to look for the beginning and the end, preferably on a slightly smoother version of the data here. It gives less room for error, but we would try to come back to the rawest of forms of data as quickly as possible. So my point being that we can use these duplicated channels, or perhaps virtual channels, remember those are the ones that we can use for calculations to help refine exactly where we want the beginning and end of this burst for the EMG in this case. Okay, so an XY plot, unlike a data channel, measure to data channel, would allow us to say measure the beginning to end, so that the burst duration plus the area under curve into one window. We could still write the data, those measurements, to multiple measure to channel channels, and we can look at that in a second. Right, so we did a little bit of rates and interval display. I think I'd like to be offline just to explain a little bit more about the EMG burst. We've had a look at the PSTH. The same thing would, same sort of things would apply for interval histograms. We're setting up a channel, we're setting up the width of our histogram, possibly offsets. And again, we have the same process dialog each time. Once again, setting to update as quickly as possible. There we go, an interval histogram building. I can hit on this window here and now do tile vertically, and the window that I clicked on will always be top left or top left, or always be the first window in the list. So just a little hint there. Okay, right, force feedback. I've got a little script for that later. Right. So anybody got anything particular they'd like to look at right now while we're still sampling this data? Please ask. Okay. Right. So if we're going to look at bursts of EMG, we're going to have to steal away this cursor from the data view, or we're going to have to make a second data view. So I have to go to Window and Duplicate. We've got an exact duplicate of what we had before, and this cursor in the second window is now disassociated with the first, so I can I task it to do other things. Okay, so let's open this out a little bit. And for this window, cursor 0, active node. So rising threshold on channel 3A, that's fine. Let's start adding, let's just use that cursor to begin with. And cursor 1, this is just going to be fast. Active node. Let's go data falling through a threshold. And this is channel 3A again. And the threshold is the horizontal cursor. Okay, so in position to search, we might say 10 seconds. Okay, we don't know how long the burst is. So when we're using active cursors like this, we're saying from cursor 0 for up to 10 seconds, our other cursor is looking for when data falls through the threshold of horizontal cursor 1, which is set at about 0.14 volts in this case. The first time that we see a falling threshold is where the vertical cursor 1 will place itself. Now, just a reminder, to put those cursors on the screen, I used Control 0 and Control 1, but there are buttons here for adding a vertical and horizontal cursor here, as well as zoom in and zoom out. Okay, so let's have a look at how those are operating. And you see they're not quite right yet, because I'm finding there is definite changes within that waveform, which is causing this guy to find a rise and a fall. So I'm going to need to do more. Now, the more processing to this, the quickest thing I can do is just change the smoothing factor. If I increase that, there's less likelihood in this case that it's going to fall below that threshold. But I've now extended the start time to quite a bit before the EMG activity I see here is. So I might do more with the cursors themselves, saying, okay, I want to know that this guy was over for, say, 50 milliseconds. And likewise with cursor 1, I want him to be below for, say, 10 milliseconds, just to show that they can be different. Okay. There we go. So now you can see these two cursors finding the beginning and end of each burst. Now that's not perfection yet, but for speed, I think that's good enough, because we're now going to move on and take measurements from that waveform. If we had a little more time, then I would be using extra cursors to go and find the turning point, if you like, from baseline to rise, and from fall to baseline again. And for that, I'd use slope. Okay, so we're good to go there. So from this duplicate view, let's just make sure we've got our EMG coming in again. I'm going to ask this time, not for a data view, but for an XY view. Once again, the top here, what is cursor 0 doing? If you wish to, you could select user check positions. And that means if selected, that the data is presented to you each time that cursor 0 finds the feature that you're looking for. Other cursors would then, if there are other cursors that would then fan out and do their thing, you would then be asked to accept, reject the cursor positions to then for then the measurement to be taken and put into the XY plot. You could move the cursors at that point, adjusting them to suit, and accept and move on. For what we're doing now, though, it wouldn't make much sense. So I'm going to take that off, and we're going to plot, say, time at point into the file versus the time difference. And that's going to be cursor 0 and cursor 1. And we're going to duration. And we're going to add another channel, which is area. And that's going to be the area under curve. Now, there are several types of area: curve area and modulus. Modulus just makes everything positive. Curve area, instead of taking a horizontal 0 at the 0 position on the y-axis, we're now taking the intersect of the waveform with the cursor as being the first 0 position, and then intersecting to the second cursor, which may not be on the horizontal. Okay, so anything below that line would then be negative, everything above would be positive. Now, for our already rectified data, area would be just fine, and we say new, and again, update as quickly as we can. But this time we need to give a leeway for process. So cursor 0 has very quickly found the rising threshold, but we need to wait for the fall of this burst. So perhaps we should set this to maybe a second or so. These bursts are relatively short. Let's try that and see what happens. Okay. So there we go. We're now getting, I hope, yes. There we go. Durations down at the bottom here and areas plotted here. Now, don't forget, to make things a little clearer, we could change colors in any of the views. So channel primary color, we've got duration in red, area in blue. Okay. as a reminder, we want to get this data out. What you see is what you get. If I zoom into an area like so, and then go copy as text, that's what I get, what I've zoomed into, what I see. Let's try a new text document. Paste, there we go. That's my two channels, in fact, two x-axes of the same value, and then two y columns there. Okay, so that's an easy way of getting the data out. Right, so we've got quite a lot going on here. We could simplify things in terms of an XY view. Perhaps let's go back to this guy. Now bear in mind that everything is still going on in the background. Let's show hide channels. So right click, show hide channels, and I want something fairly slow. Okay, so there's respiration. Now I'm going to use this for force feedback, but we could also treat it as respiration in a second as well. I've got a joystick here, and I'm going to add this to the next channel. Hopefully, we're going to see an output. Now that's pretty slow. I think that was 10 hertz we set this to, but there could be a respiration. Cursor 0 could now be asked to find the inspiration and expiration times, inspiration or expiration times. That is a zero crossing. And then we could look at measurements of this waveform. But what I intended to do was now to hijack this cursor. In fact, I'm going to make things even more complicated. I'm going to duplicate this view. And for this one, I'm going to say cursor 0, active mode. And I'm going to look at data points. And this is going to be on channel 4. Since it's quite slow, I'm not going to change anything else. So there's a minimum step in terms of time and also point count. So I could say, get me every 10th point. But as we're looking at 10 hertz, I think we're fine at a point count of 1. Okay, so now I'm going to go to an XY view. And this time, it's going to be an expression on the x-axis. And that's going to be 0. I just want 0 on the x. And for y, I want value of point on channel 4. Okay, and that time that I want the value from is cursor 0. So remember, cursor 0 is finding every data point in that channel. And I'm going to set this to 1 data point. Okay, so new, and I'm going to stop the axes from processing. No leeway, because I don't have to wait for anything else. Cursor 0 is there and triggering the measurement. And apply. Okay, now let's make this a little smaller. Let's get this showing you what's happening in real time. Okay, here now the XY view. And if we take the x-axis and move it over so it's now centered, okay, and we bring this to a few volts. So there's 0. And there's, say, 4 volts either side. Right. Now, as a form of force feedback, there is a data point, a single data point, which represents the waveform, the force being applied in this case. Now, we can do a couple of other things here. We can say channel draw mode, set this to dot. We can have it as a plus and more of a target, and set the size quite large. There we go. Right, now, what you'll notice is that this is rather erratic, it's following every data point, or trying to plot every data point is plotting every data point that we find. So I'd like to slow that down. Because of force feedback, we don't want it jumping around so much. So what I can say to this data is, let's go to process settings and set a width. So we're now going to take a mean over, say, half a second. Now it's half a second either side there, usually. So apply and OK. Now you'll see it looks a lot smoother than it was, so much better for feedback to the subject. Now, if I was to go further with this, I'd probably employ a script to make the crosshair that I've got even more visible, perhaps a solid line across the screen, or some other shape or object that you'd like to see. But anyway, as a simple example of getting some force feedback, there we go. Okay. Right, now as usual, we're fast running out of time. So we covered quite a lot with just the online analysis so far. I think if we just duplicate, tile vertically, you can see there's an awful lot going on already. So Spike2 has managed to keep quite a lot of analyses going. The XY views, the PSDH, interval histograms, etc., all running there while sampling. Okay, now if we stop this, okay, and I'm just going to pop these away for a second, like that. Oh, one thing is, if you wanted to get rid of everything quickly to close them, you could select a range like this and close windows from this window pull down, window and windows. There we go. Right, let's see if this will work straight off. So again, the force feedback, I'm just going to change channel just in case. And so this is a script using a yes, use voltage values. So we're going to go for 5. Okay. So let me just check the right channel for that. So channel 5, that's port 3. Okay, so once again, the joystick, pop that away. Average, I should have really cleaned up after this. Okay, in fact, let's just do that. Let's go to sampling configuration. Oops, abort. Sampling configuration, reset everything again. Just get new waveform, set 1000 Hertz. Okay, now I'll run the script and make it much simpler. So calibrating here, we don't want those, we want voltage, okay. And we can start. So it should be on the first channel. Okay, with this script, just as an example to show it can be done, because it's been asked for several times, we're waiting for a bleep from the machine, and then we're to follow a pattern. Now that pattern could be fast section, medium section, slow section. So we would have a ramp, plateau type arrangement. So okay to that. So okay. Oh, damn. Right. It's my mistake for having everything not set up correctly. So I think, yes. All right. Apologies. I will fix that. So let's go. Windows. Let's get all of this and throw it out. So close Windows. Okay. Right. So let's see that this will do its thing. It certainly did earlier. So why am I getting two windows? Let's start. I'm just going to try this one more time. Otherwise, I'm going to have to reset absolutely everything. And say, okay, yeah, it's not going to work. Okay, right. I need more time with that to get it going properly. Right. The idea was that in the XY view we draw the ramp, and unfortunately it's not there. No, we draw the ramp and then we overlay the incoming force data. Now, the incoming force data is already recorded into the data file. That's fine. The ramp, being in the XY view, could also be copied to the data file at the time it was presented. And that means you could then use virtual channels. Again, remember them, they're the ones that allow us to do calculations of channels, supplying an expression. So we could see the difference, you know, so when the force was on target and when not. Okay, so let's get rid of that. Let's abort that. Okay, so that's clean now. Now, where else did we want to go? We've done some online processing. We haven't done anything about burst analysis, so I think that's probably the next step. So we're going to take, let's take a trusted file here. Let's just use demo. Okay, and use standard display. Right. So we've got spiking data. That is, I've got a channel here, channel 3, the response, which is an event. It's a time, it's a marker, just like a spike wave mark channel would be. Now I could go up to script here and evaluate, and I could type in burst make and give the parameters for this command, and then I can apply that to the channel, which would then write to a new memory channel the burst start and end positions. But much easier than that is to go and use one of the already created scripts, ones that are there in your documents folder, and then Spike 7, 8, 9, 10 scripts, and we have script files, and we've got burst. Okay, so if we run this, mark burst, which channel we're looking for is channel 3. We're using dialogues to perform, to specify what a burst is. Fixed. So we're saying the parameters for a burst here, so 80 milliseconds and 160 milliseconds, the longest interspike interval, and there must be 2 bursts or more, 2 events or more for a burst. So okay, and now you'll see that the burst channel has been created. So, so very quickly, we've gone from our wavemark channel or event channels we have here. We've created a burst channel. Now we've got that information, we can get even more detail out of it. How many spikes were in each burst, the mean burst durations, etc., etc. All that within one of these scripts. Now we have many scripts given to you as part of Spike2. There are many scripts on our website, and we have many thousands more here. Anything from just a few lines that we wrote for somebody just to save them time, through to rather extensive scripts for dealing with a whole slice preparation experiment. So please ask if you're not going to, if you don't feel you can write your own script, come to us. We're bound to have something already that may suit. If not, it could be modified, or we can help you write your own. Okay. So let's think of just finishing up here. I think again to you, I know this isn't the same as an in-person meeting, but if you'd like to see anything else before we finish, please ask now, and I can try and run through it. Okay, let's just abort that and quit. Okay. All right. Perhaps then, before anybody comes in on the chat, getting data out. We have on our data file here a text mark channel. Perhaps we should see this in a different mode, a channel draw mode, change it to state. Hopefully show the text. I hope there's text in there. Yes, so we've got different sections there, which probably relate to zero crossing by the looks of things. Yes, I would say so. Okay, so you can see the text written there. Remember, text mark channels are good for annotating the data. We could also see these as vertical markers. So I've got to get the right channel, channel 9. Display the text, and we could have the same color. There we go. And now if I zoom into a smaller area, you can see that this text here is now appearing in the vertical section there. Now it's much messier, of course, as we zoom out. But for those of you who are doing long-term recordings, drug additions, etc., then the text marks are a very good way of annotating the data, far better than the keyboard marker in my mind. Right, now we want to get this data out. We could, again, have gone to the Show Hide Channels dialog, and there we could set the scale bar options for both channels. Now, these can change in size depending on what you set as the large tick spacing. So if we set that to 2, you can see how the scale bar has changed. Now, the same is true for the y-axis, independently, that is. Okay, we could now go to File and Export As. We could, as I mentioned early on, write this data out as the 32-bit version because we're sending it to somebody who's got an older version of Spike2. We could cut down our data file into one of these two formats, the 32 or the newer 64, perhaps cutting off the first 30 minutes, which was just preparation. There's nothing interesting there. You don't want to keep it. Cut it off, so we export from 30 minutes in up to the end of the file. If we're exporting times, we could also specify which channels to output, and these could then be sent to a spreadsheet, which is usually what you want for taking into programs such as Excel, or a text file, which is not so useful in terms of being able to export it to Excel, as this produces one channel after another in a single column, maintaining the original sample rates. And because these channels are sampled at different rates, it's not going to make a nice rectangular output for programs like Excel. So spreadsheet would be the way you want to go. But by far, many people would want to export as an image. We would recommend the enhanced meta files. And if not an image, then people would like to export to MATLAB. There we go. So there's the last option in the list there. Right. Now we've gone a little over time. So please, if anybody's got any questions, please ask now. So I think we're about 10 minutes over. Yeah. Okay. So I'll give you just a few moments, but if there's nothing you wish to see further, then thank you very much for your time today. And we'll see you, I hope, when we start doing a little bit of scripting. Okay. Thank you. Okay, right. So we'll say goodbye then, and thank you again.